Hi everyone, welcome back to Geeks for Geeks. In this video, we'll be discussing the problem flatten BST, that is a binary search tree, to a sorted linked list. So in this particular problem, you will be given a binary search tree. You will be basically given the root of the BST, and your goal is to rearrange the BST in the form of sorted list. For example, if you will see the case where you have been given the tree, that is 5 has a child 3 and 5 has a right child 7, then 3 has a left child 2 and 3 has a right child 4. Okay, 7 has a left child 6 and 7 has a right child 8. So if you will see this overall tree which is behaving as a BST, it is following the properties of the BST. That is, for a particular node, its left child is having data lesser than it and its right child is having data greater than it, right? So we have to take all the values of this BST, and then at the end of the day, we have to convert it into a sorted list, which you can see here. So basically, first of all, 2 is the smallest value, it should be there, then 3, then 4, then after that 5, then 6, then 7, and then 8. So how can we solve this, or how can we do this? So basically, there is one property of BST that we can use here. Okay, and the property of the BST is that in a BST, if we do the in order traversal, okay, inside a BST, if we do the in-order traversal, then in-order traversal of a BST basically is in ascending order. Okay, ascending order, or you can also say it as sorted order, right? So what happens is, inside a BST, if you do in-order traversal, then the data that you will get, it will be in sorted format, or you can say in the ascending order format. Let's take one example. What is first of all in-order traversal? So in-order traversal is basically firstly left, considering the left, and then processing the root, and then calling for the right. So this is the in-order traversal. That is left, then processing the root itself, then going to the right. So suppose if you had a BST, let's say 4, then you had got 3, and then you had got what? Like, let's say 5. So now in this particular BST, you will start from the root node, okay? And first of all, you will go where? You will go to the left. So when you go to the left, you will go to 3. Now 3 is the current root that you are at. Now for 3, you will go to the left. That is, on the left you find null. So if you find null, you will return, and with respect to 3, you are returning from the left. So whenever you return from the left, then you will process the root. So then you will process the node, that is 3. Okay, then after that, what will happen? You will go to the right, because now 3 has been processed. So you'll go to the right. The right of 3 is also null. So since it is null, you will return. And for 3, you have processed the left as well as 3 as well as the right of it. So you will go back up, and with respect to 4, you are coming back from the left. So when the left call is over, then the root will be processed. So 4 will be processed after that. And then what will happen is, you will go to the right. That is, you will go on 5. The moment you go to 5, so 5 will behave as your current root. And with respect to 5, on the left, you will go to the left. The left is null. So you'll return away there, and then you will go to 5. Now, when you are at 5, so it will behave as your current root. Okay, because for 5, you have already gone to the left and you have come back from there. So now you will process 5. And then after that, you will go on the right of 5. So the right of 5 is null. So you'll simply return from here. And then with respect to 5 also, you'll return from here, and this is how the traversal is over. And at the end of the day, you can see that you are having 3, 4, and 5, and you can see that the data is in which order? It is in sorted order. Okay, so the list will come out in sorted order. This is basically the property of a BST, that if you do the in order traversal, firstly you call on the left, then you process the root, and then after that you call on the right, then you will get things in sorted order, right? So let's take this example again, so that we can finally come to one conclusion. Okay, so you'll be having 4, then you'll be having 3, and then you'll be having what? 5, right? Suppose this is the BST that has been given to you. So now if this is the BST that has been given to you, so you have to prepare a final list. For that, you can declare a head, and you can also do what? You can declare a current node. Okay, so initially the head and the current you will be marking as null. Okay, initially you will say that it is null, there is nothing inside. Then after that, you will start from the root node. Then for this guy, you will go on the left. So you'll go to 3. For 3, when you go on the left, what happens? It is null, so you return. Then you will process what? Then you will process 3, because you are doing the in order traversal, as I already discussed. So now, since you are at this particular node, so you have to process this particular current root node. Okay, so So you will check, is the head equal to null? Yes. If the head is null, then what you will do is you will simply say that you will make this node, that is the current node 3, as the head node and the current node. Okay, so now this node 3 is going to behave as your head node as well as the current node. Now after that, when you will go up, right, so when you go back after 3, the call is over, so you go to the right of 3, there is nothing, then you will go back to 4. When you go to 4, so now you will check, is the current head null? No, the head is not null. If the head is not null, then you will say that with respect to current next, you want to insert the for the current right guy, because since you are using the node of the tree only, right, you are not changing anything else. So with respect to current node that you are at, its right would be updated to what? Its right would be updated to this particular root node. So you'll update it to 4. Like actually inside the tree with respect to 4, 3 was stored, right? So you will make the roots left as null first of all, the current root that you are at. So this connectivity will be lost, and then what you will do is you will say that current right will be the current root node, will be the root node that you are at currently. And then after this, what you will do is you will move your current to current next. So current will move here. Okay, current will always be pointing to the latest node of your list, sorted list. Okay, now after that, when we go down, we go to the right, so we go to 5. Now for 5, when we go on the left, so we don't have anything, then what happens is we go to 5. The moment we are at 5, then for 5 we come back from the left and we are at 5 now. So when we are at 5, so 5 does, like, left is already null, but still you will make its left as null. First of all, the current root that you are at, you will make its left as null, and then you will say that current's right will be updated to the root node, and then you will move your current to the current next. So current will be pointing here, and this is how you can see that I have got the list, that is 3, and then I've got 4, and then I've got 5, and I have got the head pointer standing here, and current is standing at 5, head is standing at 3. So basically if I return the head, that is the node 3, then I'll be able to access the rest of the sorted list here, and that is what the problem wanted me to do. So what I've done is basically I've used the property of BST, that is in order traversal gives me a sorted order of the BST, right? I've used this property and I've used the concept of normal linked list or tree in order to solve this particular problem, right? So let's try and quickly implement the code, but before that, if you will discuss the time and the space complexity. So for my approach, since I am doing what? Since I am traversing all the nodes, so it would take order of n time in the worst case, because you are iterating through all the nodes. And what will be the space complexity? The space complexity of my code would be order of n in the worst case, because if the tree is skewed in nature, then this would be the recursive stack space that I will have to pay for. Okay, so now let us try and code this problem as well to check if our thought process is clearly working or not. Okay, so let's quickly open the compiler and try to write a bit of code here. Okay, so what all I need? So I need a node star, let's say head. Okay, and head would be initially null. Okay, and then I also need a node current. Initially it will be also null, right? So this will be what I need is, firstly I need a head, and then I need a current node, because because head will be fixed. After head is fixed, then my current will always keep on moving forward, okay, indicating the current latest node of the sorted list. Okay, then after that, what I will do here is I will say that we will call one function, that is, let's say, in order function, and here I'll pass the root node, I'll also pass the head node, and I'll also pass the current node of the linked list. Okay, now after this is done, after this in order traversal will be done, so my head node will be storing the head of the sorted linked list. So at the end of the day, I'll just return the head node. That is what my idea is. And here if you will see, so what will we write in this recursive code? So what we will do here is, firstly we can say that it can be something like void in nature. So I'll write void in order. Okay, and then after that I'll write node star root. So firstly I'm writing the root, and then I'll write node star ampersand head. Okay, because I'm passing it by reference, so that any changes that I make to the head, they should be visible. Okay, and then after that I'll also write node star ampersand current. So I'm passing the current and the head by reference. Okay, and as I said, if what happens is, if the current root that I'm at, if it is null, so then I don't have to do anything, right? So then I will simply return from there. Okay, that is what I have to do. Otherwise, firstly I will call the in order function, and I'll call where? I'll call on the left of the current root node, because firstly I have to process the left, right? Firstly I have to call on the left, then I have to process the root node, and then after that I have to call for the right. That is what we do in order traversal, guys. So what I'll do here is I'll pass the head and then I'll pass the current as well. Now once this is done, so I have to process the root. So what I have to check is I have to check if my head is equal to null. What if my head is null? If my head node is null, then in that case, I can say that this is the first node that I'm getting. The current root node is the first node. So I'll update my root head to the root node, okay? And I'll say that my current will also be equal to the root node, because if this is the very first starting node, then I need to update my head as what? Then I need to update my head with the root and current with the root as well. Also, one more thing that I should do is that I will update the heads left as null. Okay, why? Because for the head there should be nothing on the left. Okay, then after that else if I'm processing the current root node and it is not the first node of the list, then I will say that what I should do is for this particular root that I am at, I should mark its left as null. Okay, because if it had something on the left, now it should not contain anything on the left. And then what I should do is I should say that current is current's next. Okay, current's right basically would be equal to what? Would be equal to this particular root, and then we will say that current is equal to current's right. So we'll move our current one position on the right, that is it will move by one step. This is just like doing I plus in the normal looping format that you do in a normal array. Then after this is done, after you have processed the root, then you will do what? You will call the inOrder function for the right part, okay, and then you will pass the head here and you will pass the current here as well. That is what we have to do in terms of code. Now let us just try and compile this on the samples and check if our code is working fine or not. So you can see it is working fine on the sample test cases. Let us try and submit this code to check if it is getting accepted or not. So you can clearly see that the code that we have written, it was able to pass all the test cases, and I hope that everyone is clear. Now talking about the companies which have asked this particular problem, there are companies like Amazon which constantly ask such kind of BST problems where you have to use the inOrder property. So just in case if you have understood this problem clearly, make sure to comment down a +1 or understood in the chat, and do let me know if there is anything that I can improve. Thank you for watching this particular video.